So in today's video, we'll be studying about Bonferroni's inequality, which states that the probability of intersection of n events is always greater than equal to the summation of the events minus the number of events minus 1. So let's just break it down for better understanding. So this thing is nothing but P of A1 intersection A2 intersection up till an greater than equal to the summation of individual probabilities, that is P of A1 plus P of A2 up till P of an minus, I'm writing it in a different line, n minus 1, the number of events minus 1. This is simply what it means. So let's just begin the proof. So we will obviously be using method of mathematical induction to prove it. So okay, now we all know that any probability, in this case we are taking A1 union A2, this probability will always be less than equal to 1. Okay, now from theorem of total probability, this thing can be written as P of A1 plus P of A2 minus P of A1 intersection A2 is less than equal to 1. Now taking this to the other side and bringing the 1 on this side, we get P of A1 plus P of A2 minus 1 less than equal to P of A1 intersection A2. Let's just rearrange it. So P of A1 intersection A2, I'm just rearranging, that is I'm bringing this thing on this side and this thing on this side, nothing else. So P1 A1 intersection A2 is greater than equal to P of A1 plus P of A2, and I'm writing this 1 as 2 minus 1. Now are you getting familiar with the thing where this is going? So this is for n equal to 2. So this is the n number of events. So this is the Bonferroni's inequality for n equal to 2, and hence it is proved that Bonferroni's inequality holds for n equal to 2. Let me just move this like here. Yeah. So we can now just move on with the proof that let us assume that the Bonferroni's inequality holds true for n equal to m, that is P of intersection I is equal to 1 to m ai is greater than equal to P of, okay, not P, summation I is equal to 1 to m of ai plus minus n minus 1 m. Sorry, we will assume this as equation number 2. So we have to prove it for n equal to m plus 1. So let's just write it down. P of intersection I is equal to 1 to m plus 1 ai. This thing can be written as P of intersection I is equal to 1 to m ai, just like we did in our Boole's inequality proof, the link to which is shared along with this video. So it is nothing but like this, we are dividing it in this fashion. Simple stuff only, I'm just describing it again. So what I did is I did nothing actually. So I've just written it in a form that a1 intersection a2 intersection up till intersection am plus 1. I've just put a brackets here and defined two of them as two different events. This one as event v1 and this one as event v2, like that. So we can write it that this one is p of v1 intersection v2, and we have already proved that this one is greater than equal to p of v1 plus p of v2 minus of minus 1. Yeah, we have already proved this. Now let's just break it down. So p of I is equal to 1 to m plus 1, ai is greater than equal to, now let's just break open these things. So probability of b1 is nothing but b1 is nothing but this thing, and b2 is nothing but this thing. So b1 can be written as intersection I is equal to 1 to m ai plus p of a m plus 1 minus 1. Okay, now we know that this thing is greater than equal to summation I is equal to 1 to m p of ai minus m minus 1. We know this from equation 2. This part is greater than equal to this part, so that is the only thing that we are writing here. So from 2, so now we can write it down as summation I is equal to 1 to m p of ai plus p of a m plus 1. Okay, there's another term in between, plus m minus 1 plus p of a m plus 1 minus 1. We can further write it down as, so this can be easily simplified, like this can be written as summation. So I'm clubbing these two terms. This can be written as summation I is equal to 1 to m plus 1 p of ai, and I'm clubbing these two terms. I'm writing it in a different way, so it will be written minus m plus 1 minus 1. This will be a minus sign. Sorry for the mistake. This would be a minus sign. Yeah. So we are seeing that it is holding for, so what it ultimately becomes, p of intersection I is equal to 1 to m ai is greater than equal to summation I is equal to 1 to m plus 1, this m plus 1, sorry, p of ai minus m plus 1 minus 1. That is, the inequality holds for n equal to m plus 1, and thus by mathematical induction this theorem is proved. If you like this video, do share and subscribe and give it a thumbs up. Thank you.